Hi everyone, we are AUG23 group. My name is Tae Hui.
My name is Derek.
My name is Kai Hong.
Okay, for today our topic is application of conic section in real life. Actually, the conic section is always using in our real life. There is some examples such as bridges, roller coaster, and boats. First of all, we should know what is conic section. Conic section is a curve obtained by the intersection of the surface of a cone with a plane. By cutting and taking different slices at different angles to the edge of a cone, we can create a circle, an ellipse, a parabola, or a hyperbola. There's the image of circle, ellipse, parabola, and hyperbola.
Why we should use conic section in our real life? For example, engineering. Engineers use the principle of conic section to build and design dams, bridges, and roads to ensure stability and optimize structure design. For satellite orbit, the orbits of satellites are characterized by conic section. The knowledge is essential for the design and operation of communication, navigation, and Earth observation satellite. For art and design, conic sections have been used for centuries in art and architecture, shaping structure and buildings. For example, parabolic shapes are incorporated into the design of iconic architecture landmarks. For the definition of parabola, a parabola is a set of all points in a plane that are equidistant for a fixed line, the directrix, and a fixed point, the focus.
As you can see, when we draw out the parabola graph at the 2D paper, it's more likely like a U-curve shape that will either open upwards, downwards, open to the right or to the left. And there is two standard equations that can help us to differentiate how does the curve look like. If the standard equation is equal to x minus h squared equal to 4py minus k, then the curve will be open upwards or downwards. While if the equation is y minus k squared equal to 4px minus h, then the curve will be open to the right or to the left. And from the parabola graph, the first thing that we should know is the vertex, which is given by the coordinate of hk. The vertex can also be defined as the minimum point in the U-curve shape and is located at the midpoint between the focus and the line directrix and is separated by a distance of p. The p-value here also will give us info that how does the curve look like. If the p is greater than 0, then the curve will be opens upwards or to the right, while if the p is smaller than 0, the curve will be opens downwards or to the left. One thing that I want to add on here is the latus rectum. The latus rectum is actually a chord that is perpendicular to the axis of symmetry and it will passing through the focus. In simple words, I will pass up to Tae Hui for the further explanation.
Okay, I will simply explain the curve. As for the first one, there is the left-right curve. The equation for it is y minus k squared equal to 4p bracket x minus h. Vertex is h, k. Focus is h plus p, k. Directrix is x equal to h minus p and axis of symmetry is y equal to k. Length of latus rectum is 4 modulus p and the direction is if p larger than 0 open to the right and the p smaller than 0 it will be open to the left. As for the upwards and downwards curve, it will be the equation of using x minus h squared equal to 4p bracket y minus k and the vertex is h, k, the focus is h, k plus p, directrix is y equal to k minus p, axis of symmetry is x equal to h and the length of latus rectum is 4 modulus p, direction is p if larger than 0 it will be open outwards and p smaller than 0 it will open downwards.
For question 1, at a water fountain, water attains a maximum height of 4 meters at a horizontal distance of 0.5 meters from the origin. If the path of water is parabola and assume maximum height as vertex, find out the focus, directrix, axis of symmetry, length of lattice rectum, and sketch the graph too.
Okay, so before we find out the focus, from the equation we know that the maximum height is at point 0.54, and as the parabola curve have maximum height, it means that the curve is open downwards, which also gives us info that p is smaller than 0. As the maximum height is equal to vertex, so the vertex is also equal to 0.54. So to find out the equation, we just use the equation x minus h squared equal to 4p y minus k. So we just substitute into the h and k value, which is the vertex, and we can find out the equation. So until here, we still haven't know that what is the value for p. So we need one of the coordinate from the curve, which the question already mentioned that the origin x equal to 0, y equal to 0 to find out the p value. So when we substitute into the x equal to 0, y equal to 0 into equation, then after we rearrange the equation, we can find out that the p is equal to negative 1 over 64. So after that we got p, we can just use the formula focus h k plus p to find out the point of the focus, which is 0.5 255 over 64. For b, the question asks us to find out the directrix, which is a line that parallel to the x-axis and located outside the curve. So we know that we can use the formula of y equal to k minus p, and we already find out the p value, so we just substitute inside and get it. Y is equal to 257 of the 64. So for 3, it's just very simple. It asks us to find out the axis of symmetry. Just use x equal to h, and we know that h is equal to 0.5, so the axis of symmetry will be x equal to 0.5. For D, the question asks us to find out the length of the lattice rectum. Also, we have also the value of P, so we just use the formula for modulus P to find out the length of the lattice rectum. So although our P is in negative value, but when we put inside the modulus sign, it will turn to positive, which gives us that the length of the lattice rectum is equal to 1 over 16. For the last one, it asks us to sketch out the graph. So we know that we just simply draw out the x-axis and y-axis, and we already know that the curve is open downwards and start from the origin. So we just draw a reverse U shape that lies on the x-axis. So the first one, we just point out our vertex, which is at a point 0.54. And for the focus, we know that it's inside the curve, and we also already know the coordinate equal to 0.5 255 over 64. The third one, we should draw the line of the directrix, which is parallel to the x-axis and located outside the curve, and it will be at the line of y equal to 257 over 64. The axis of symmetry is very simple. It's just a line that passes through the directrix, vertex, and focus at a point of x equal to 0.5. And for the last one, the length of lattice rectum, we already know that the lattice rectum is the line that passing through the focus. So we just draw a line that passes through the focus, and we also know that the length of the lattice rectum will be 1 over 16. So that's all for the sketching of the graph.
Okay, for the continuing question, there is the question asking us from the equation of the parabola above, we need to find the height of the water at a horizontal distance of 0.75 meter of the point of origin. As we know the curve is open downwards, we need to use the equation x minus h square equal to 4p bracket y minus k. Just now we already proved that the p is equal to negative 1 over 64, and we can get the x and y from the equation. There is x is 0.75 and the y is unknown, so we substitute all of them is into the equation. We calculate it and rearrange until final, and we can get y equal to 3, and the point we will get 0.753. And overall, the conclusion and summary of parabola, we can know the vertex of parabola is always located at the midpoint between the directrix and the focus along the axis of symmetry. After that, the axis of symmetry is the line through the focus and vertex perpendicular to the directrix. The latest rectum is a chord perpendicular to the axis of symmetry and passing through the focus. If p larger than 0, the curve of the parabola should open to the right or open outwards, and if p smaller than 0, the curve of the parabola should open to the left or open downwards. There is the references that the image or some resources that we use over all the slides, and there is the link. That is all for today.
Thank you.